Hello, so welcome. We're going to be looking at P10 lesson 1 today, which is Newton's second law and how do we work out Newton's second law. So please make sure your phone is off, you've not got the TV on, not playing any games or anything to distract you, and you've got your booklet with you as well. If you're ready, we shall begin. So we're going to look at some new information. So Newton's second law, so this is after Isaac Newton, that great British physicist. And it states that the force applied to an object is directly proportional to the acceleration. What we mean by that is that if I apply a force, it will accelerate at a certain rate. If I double the force, the acceleration will double. So if I double the force, the acceleration doubles. So it's directly proportional. So if I triple the force, the acceleration triples. If I halve the force, the acceleration halves. And we can write this as F, this funny little squiggle sign, A. So this squiggle sign means directly proportional. Proportion. I think that's about right. Directly proportional. This is really, really useful in science if something is directly proportional because it means we can calculate things a bit easier. We will have a look at the required practical in the rest of lesson 1 in your next lesson. Now, Newton also determined the mass of an object also affects the acceleration. So a more massive object, something that's heavier, will accelerate slower than a less massive object, so a lighter object, when a force is applied. And if we think about that, well, yeah, that makes sense. If I have something that's really heavy and I try and push it, it's not going to move very fast. It's not going to accelerate very fast. It's very, very light and I push it with the same force, it's going to accelerate a lot quicker. That's why if you've got a ball, saying you want to throw a ball, it's a lot easier to throw a tennis ball than it is a bowling ball. You have to put more force on the bowling ball to get it going with the same acceleration. And through a bit of maths and some experimentation, he was able to determine that the force applied to an object will be equal to its mass multiplied by its acceleration. And we say that as F equals ma. So it's force in newtons is equal to the mass, and importantly the mass is in kilograms, times by the acceleration, which is in meters per second squared. To remember these units, these are our base units, so newtons, kilograms and meters per second squared. We're always going to work in those. If it's in grams, we're going to have to convert it to kilograms. So we're going to have a look at some examples of how to do this and what's going on with it. So a car of mass 1,000 kilograms accelerates at 15 meters per second squared. What force is required to cause this acceleration? So we're going to write down our equation or our formula, F equals ma. We're going to have a look at what we've already got. So we've got the mass, we've got the acceleration. So we can now, so we'll have mass is 1,000 kilograms and acceleration is 15 meters per second squared. We can now put these into our formula. We can have our force is equal to 1,000 kilograms multiplied by 15 meters per second squared. We do that on our calculators, we get 15,000 newtons. And there we've done it. We've worked out our first one. We're going to have a look at some more and go through them and try a few more of them. So a train of mass, 25,000 kilograms, accelerates at 2.5 meters per second. What force is required to cause this acceleration? So again, we're going to have F equals ma. We're writing our formula. I'm going to find my mass. which is 25,000 kilograms. My acceleration is 2.5 meters per second squared. I'm going to insert these into my formula. So I'm going to have my force is equal to my mass, which is 25,000, times by my acceleration, which is 2.5 meters per second squared. I'm going to do that on my calculator, because again, I can't do that in my head. I don't expect you to be able to do it in your head. 25,000 multiplied by 2.5, and that gives us 62,500 newtons. If you followed along with that, we're going to do a few more worked examples. If you're feeling happy with those, do them yourselves and just check that you've got the right answer, and you can move on to the questions. So a cyclist applies a force of 5,000 newtons to their bicycle of mass 250 kilograms. What is the acceleration of the bicycle? Now noticing we're trying to find the acceleration now, so it's something slightly different. Still going to start off the same way. I'm still going to have F equals ma. But this time I'm going to need to rearrange my equation. Now this is just a linear rearrangement. Can either input the numbers first and then rearrange it, or I can rearrange it first. I'm going to rearrange it first. So if I rearrange it to make acceleration, because that's what I want to find, the subject, I'm going to have my acceleration is equal to force divided by mass. And my force I've got here is 5,000 newtons. My mass is 250 kilograms. I'm going to put them into my equation. So I have acceleration equals 5,000 divided by 250. Again, I'm going to use a calculator. I don't want to make any mistakes. I know roughly the number I'm looking for. I don't want to make any mistakes while I'm doing it. And I get my answer though as being 20 meters per second squared. That's my acceleration. So I've remembered to rearrange my equation. I don't just go, I've got two numbers, I'll times them together. I've rearranged my equation. Another one now. So a runner starts the race accelerating at 10 meters per second squared. They push off with a force of 700 newtons. What is the mass of the runner? Same thing again. I'm going to write down my equation. F equals ma. This time I'm going to rearrange to make mass the subject. But there, we're going to rearrange to make mass the subject. I'll stick it up there as well and say that I've rearranged to make A the subject. So in this time, I'm going to have my mass is equal to my force divided by my acceleration. Same thing, I'm going to work out what I've got. So my force is 700 newtons. My acceleration, got here, is 10 meters per second squared. And I can put them into my equation and get my mass is equal to 700 newtons divided by 10 meters per second squared. And that will give me 70 kilograms. And that tells me I'm pretty happy. I'm fairly happy with that answer. I know a runner is going to be about 70 kilograms. If I times them together, I've got a mass of 7,000 kilograms. I think we can all agree that's probably quite far off. We're going to have a look at one more worked example now before you do some questions. So a car with a mass of 1,250 kilograms has an engine that provides a driving force of 5,200 newtons. At 70 miles per hour, the drag force acting on the car is 5,100 newtons. Find its acceleration at 70 miles per hour. Whoa, we've now got miles per hour. We all said that acceleration was in meters per second squared. And that's all right, it still is. This question may look a bit scary, but you've got all the tools to do it. So we're going to start off by going, right, what do I know? I know my equation, F equals ma. So I know that already. I'm going to rearrange to make A the subject. Because that's what I want to find. I want to find the acceleration. It tells me there I want to find its acceleration. So that will give me A equals F divided by m. It's just a simple rearrangement. I'm now going to work out what I know. So I need my force and I need my mass. So I'm having a look. My force, I've got two things of force there. I've got a driving force. And I might draw it out. That might help me a bit, try and work it out. There's my car. You can see through it. It's got a driving force of 5,200 newtons, which is going this way. I've got a drag force of 5,100 newtons, which is going the other way. Now, I'm looking at this and going, I remember doing resultant forces. I've just got to take them away from each other. Luckily, they're acting in the same plane, so there's no angles involved. There's no trigonometry I need to do in there. So I'm going to do 5,200 minus 5,100. 5,200 minus 5,100. And that will equal 100 newtons. So it's got a force going in its forwards direction of 100 newtons. Its mass, I've already been told, is there. It's 1,250 kilograms. I can now input these into my equation. So I'll have my acceleration equals 100 newtons divided by 1,250 kilograms. Again, I'm not going to expect you to do this in your head. You can use a calculator for these things, but that gives me an overall acceleration of 0.08 meters per second squared. And that is my answer there. We're now going to have a look at some questions for you to do. So these are the first 5 questions in your booklet. Please pause the video now to complete these questions. When you're ready, you can press play and mark your answers. Do look out for question 2. Make sure you use the mass as kilograms and not grams. You need to convert it there. So you should now only be watching if you've answered all 5 questions. You can now mark your answers. Well done if you got all 5 of those correct. We will do some more practice on these in the next lesson, and we'll look at the required practical and the rest of the questions from lesson 1. So looking at actually how do we work it out. Thank you very much for watching. I hope it's been informative and I hope you've enjoyed it. Thank you very much. Take care. Bye-bye.